Hi everyone. So this video is going to be about union and intersection. So we're talking more about Venn diagrams, and again we've got some new vocabulary and some new symbols. So let's just dive right in. So union and intersection are often spoken about together because they are kind of like, I don't know, two sides of the same coin almost. So when you're talking about union, so the symbol for union is this sort of, it's almost like a flattened out sort of U. And so that one's kind of easy for me to remember. I think about the U in union, and then the symbol kind of looks a bit like a U. So that one's sort of easy for me to remember. So what union means is all elements belonging to A or B or both. So in the diagram that we have here on the side, union is represented by everything that is shaded in green. So it's everything that is in A, it is everything that is in B, and it is everything that is in the middle. So it's everything that encompasses both of those circles entirely, plus the overlapping section. So union is everything in A, everything in B, and everything that's in both. So intersection, on the other hand, which perhaps is maybe a word that you're more familiar with the definition of, intersection is kind of like where two things cross over. So the symbol for intersection kind of looks like a slightly flattened out N. And again, I think of intersection with the N shape. So that's sort of how I keep them straight in my own mind. The intersection of two sets, A and B, is everything, all the elements common to both. So here it's shaded in red. So intersection is only where those two overlap one another. So it's only the elements that exist in both sets. So if you look at the interval notation here, X must be a member of A and it must be a member of B. But with union, it's a member of A or it's a member of B, or it's a member of both. So union and intersection, two words you just need to kind of remember, symbols that go along with them. So next new vocabulary term is disjoint sets. So two sets, A and B, are said to be disjoint if they have no elements in common. So the intersection results in an empty set. There is, if you had a Venn diagram set up of A and B, and you entered all of the bits of data, whatever it turned out to be, and you ended up with nothing in the middle, no overlapping, the intersection is an empty set, they are considered disjoint. If they do have elements in common, they are non-disjoint, so just the opposite of disjoint. So disjoint means that two sets have no common elements. Okay, let's work our way through an example problem here. So this is typical of what you'll see in this sort of section, where you're given some information about a universal set. In this case, we're talking positive integers less than or equal to 12. And then we have set A are the prime numbers less than or equal to 12, and B are factors of 12. So first part here, we have part A, list the elements of set A and B. So if we're talking prime numbers less than 12, we've got 2, 3, 5, 7, and 11. So those are the prime numbers that are less than or equal to 12. And then set B are the factors of 12. So we've got 1, 2, 3, 4, 6, and 12. Okay, so there's the elements listed. Now it asks us to show A, B, and U on a Venn diagram. So start with our box for our universal set. Then we have our two circles. One will be for set A, one will be for set B. And remember, I like to try to do them in order, the universal set, just to make sure I'm accounting for every single number. So 1 appears only in set B. Maybe I'll change my color. So 1 is in set B. 2 is in both A and B. 3 is in both A and B. 4 is just in B. 5 is just in A. 6 is just in B, 7 is just in A, 8 is in neither, so we'll put that on the outside. 9 is in neither, so we'll also put that on the outside. 10 is in neither, so it also goes on the outside. 11 is in A, and 12 is in just B. Okay, so now that we've got our Venn diagram, so that, I guess I should have labeled that part B, then we can move on to part C. So part C, we're asked to list the elements in A prime. So A prime, if you'll recall, is the complement of A, so it's everything that is in the universal set that is not in A. So doing this numerically, 1 is not in A, 2, 3, 4 is not in A, 5, 6, 7, 8, 9, 10, 12. Those are all not in set A. Second one, so now we're looking for the intersection of A and B. So everything that is in both A and B. So that's everything that is in the center, so that is just 2 and 3. And then third part, we are asked for the union of A and B. So it's everything that is in A or B or both. So this is everything that's inside any of the circles, so it just excludes 8, 9, and 10 on the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the outside, 11, 12. Okay, and now moving on to part D. Part D asks us to find n of A and B. So we're finding the number of elements that exist in the intersection of A and B. So since we listed them up here in this part, we can just very easily say that there are 2 elements that are in the intersection. Oh, forgot to label that. Second part of this, we're looking for the number of elements that are in the union of A and B. So again, we did that right here. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 elements that are in the union of A and B. And the last part is n of B prime. So that's the number of elements in the complement of B. So it's everything that is not in B. So if I just sort of jot this down, so not in B, we've got 5, 6 is there, 7, 8, 9, 10, and 11. So that accounts for everything in the universal set minus what's in B. So we've got 1, 2, 3, 4, 5, 6 elements. So our answer for that one is 6. So again, that's a really typical kind of question. You need to know the symbols, you need to know what they mean, and then you need to be able to navigate yourself to either a list of elements or a number of elements or a Venn diagram or what the case may be. The other way that you'll see union and intersection questions presented is like this example. So where you're asked to do some shading. So you draw the Venn diagram and then shade the region that represents, and then it'll give you either some words as an explanation or some symbols. So in part A, we're going to draw our Venn diagram. And we're going to put our circles in, so universal set A and B. So it says shade the region representing in A or in B, but not in both. So it has to be in an A circle or a B circle, but it can't be in both. So that's inside the circles, but not the middle section. So we're just going to kind of shade in there, and we will shade in over there. So the sections they want are in A or in B, but not in both. Okay, and let's look at the second one. So again, start with our basic Venn diagram with our 2 circles, A and B, and our universal set on the outside. So now what we're asked to shade in is the complement of A, and then this represents intersection. So the complement of A with B. So the intersection of the complement of A and B. So it must be in the complement of A, which means it's not in A, and it also must be in B. So if it's not in A, that means we're not coloring in anything in the A circle at all. So everything here will not be colored in. So everything outside of that is fair game. So outside plus the rest of the B circle, except for the fact that it is the intersection of those. So it must be both in the complement and in the B circle. So that means the only section that fits the bill is going to be this other part of this circle. The outside is not part of B. So if it's the intersection of both of those things and the outside doesn't fit one of them, then we don't color that in. So we are left with only sort of the other part of the B circle. Okay, and that covers union and intersection.